All right. I have just uploaded the Excel file. Where it is? Did I? Okay. I have just uploaded one data file, but I couldn't. Oh, it is here. Maybe I will move it over here. So table 3-4 CS data. Now I'm going to do an example for chapter 3. It is about coastal marine. You have this data with you on D2L, coastal marine, on a different Excel worksheet. Okay. Any questions before I start? Let me check. I haven't had a chance to see the message using the formula. Will you be posting detailed solutions for recommended D2L? For the recommended problems, usually we'll solve it in class. I don't have solutions ready to post on D2L. So just attend class, you may have the answers, okay? I could not download the data series for the book we purchased. Is the data available electronically? Unfortunately, data is not available electronically. It is in PDF format. It is not in Excel format. For example, if you go to the textbook, it is PDF format, vital source. So this is our textbook, okay? This is our textbook. There is no Excel format. It is just this format, okay? Sorry, but I entered some data by hand into Excel. I uploaded those Excel files on D2L, okay? Test 1 practice questions. Unfortunately, there is no practice questions. I would suggest you redo the examples in class, redo the problems we solved in class. The test question will be similar to what we have gone through in class. For example, at the beginning of today's class, we solved one question, and that question involved in the beginning of this class. We did this question, and in this question, we calculated the critical value for Z half alpha. We also created the critical value for T half alpha. So during the test, I may ask you, what is the critical value when given 87% confidence interval if it is normal distribution? So this example, I give you 95%. During the test, I will give you 87%. If you know 95%, you should know 87%. You should know any percentage, okay? So just similar questions of what we did in class. Okay. Do we post the answer on the process as well? Do we only post the answer? During the test, most questions will just need answer. Some questions need steps, okay, need a process. Okay. Thank you for your question. Any other questions? Okay, now, if you want to follow my example, I already posted this data. I'm going to use this data. So if you go to data, I will give you a moment to download table 3-4 CS, table 3-5 coastal marine. This is an Excel file, and I'm going to use table 3-5. I will give you a few moments to allow you to download your file. At the same time, I'm going to copy question 3.5, it is here. Copy. Won't work. So this is example 3.5. It is on textbook, page 70, page 76. Okay. What you are, why I. So you are asked to analyze customary data. The data is here. Customary, not here. Okay. So go to the chapter 3-5, customary. This is the data. Customary. So what we are asked to do for this data, so those are quarterly sales data from 1994 to 2006. So what we are going to do. Compute 95% confidence interval for autocorrelation at time 1. At time 1. Okay, I will delete those. So this is the question. Maybe I will create he always felt the sales are seasonal. Gather the data. So I will just ask you to compute. The question asks you, compute a large sample 95% confidence interval for autocorrelation coefficient at time 1. Okay, maybe, hold on. I will just ask you to create. I will create some questions for this data. So what I will ask you to do. So question A. Create a line chart for the data, and then create autocorrelation function for like 13, time like 13, okay, and then this is question C. compute confidence interval for the autocorrelation coefficient at time lag 1. So 3 requirements based on those data. Based on the given data, create a line chart for the data. Okay, so we can go to the Excel. So I will just delete this. And to do that, you may need to, I will just recopy this data, or I will copy and paste to not affect other original data. So I will just copy and then paste data here. So I did nothing, just copy and paste. After that, I will change this to time to sequence. Okay, so 1, 2, 3, etc. So I will do that data manipulation first, preliminary work. Now I have do question A, create a line chart for the data. Okay, so I'll just select those 2 columns and go to insert. So this one here, scatter chart or line chart. Okay. So from this, you can see data of this for sure is not seasonal, is not stationary data. It is wave-like. Okay, it is also has the seasonal effect, as we can see those dots, the seasonal effect. It has the trend, it has the seasonal effect. It also has the cyclical effect. Okay, so it has the trend, cyclic effect, seasonal effect. Okay. So we answered this question A. To do question B, we need the SPSS. So I'm going to copy this data into SPSS, and I also want to use SPSS to create a line chart or scatter plot. So I just click copy.
Professor, quickly, how did you do the sequence thing to make it go 1 through how many numbers?
Thank you so much. So if you just type in 1 and 2, that's it. And then you select 1 and 2. Put your mouse on bottom right corner until you see this fill handle. Not here, not this, must be this solid cross. Then you click and drag to create a series number. See, click and drag.
Okay, thank you.
Okay. You're welcome. Thank you for asking. Any other questions?
You can also double click the square and it'll go all the way down.
Thank you so much. You double click. Oops. It is go all the way down. Correct. So you double click, because I have this little guy annoying. The other way, you double click, it will go all the way down. So just type in number 1 and 2. Then you double click this bottom right corner. It is go all the way down. Okay. So anyway, I'm going to copy this data into SPSS. Copy. Maybe I will file, new data, then paste. I don't need those 2 decimals, so I'm going to variable view first. I will change the variable. This is the time. What is those numbers? Those numbers are cells. So delimitate, no decimals. Okay, so now my data is clean. Now I'm going to create a chart. How do I use SPSS to create a chart? I go to chart, legacy dialog, and then I can create, I will try scatter plot or line chart. So simple, define, which one is my Y, cells is my Y, X is time, that's it. I'll try. This is not what I want. I want something like Excel. Give me the, okay, so I'm going to recreate a chart. Maybe I want to create a line chart instead of scatter plot. Which one I'm here, not here. Sometimes I have too many windows open in Excel. Maybe this one. Yes, this one here. Okay, line. Legacy diagram. I will try the line chart. Simple. Summary cases for group. Summaries of separate variable. Value of individual group. Individual cases. Line represent cells. Yeah, this is better. See, if I create a line chart, this is a better representation than this scatter plot. So this is a example similar to the Excel I created. Okay. So next I will answer question B. Create ACF autocorrelation function for lag 13, for time lag 13. So go to analyze, forecasting, autocorrelation, select cells, quick options, maximum number of lags 13. Okay, 13. Try to copy the screen so that I can make the notes. Okay, so this is if I compare this with the textbook answer, oops, yes, exactly the same as in the textbook answer. Okay, so you get this point, yeah. Lag 13. Okay. So I'm going to copy this into and also the output here. So this is the cells. We get the autocorrelations functions here. And we also get this ACF. From here, you can see seasonal effect, Q1, Q2, quarters. No, this you see, those are significant, this point and this point. They are above the upper confidence limit and the lower confidence limit. So this is a typical indicator of seasonal data. Seasonal data. So I'm going to copy this result. Into here. Okay. So we answered question B. Okay. Now question C. To calculate confidence interval for autocorrelation coefficient. Autocorrelation coefficient. So we are going to use formula. 3-2 formula. Okay, so I'm going to show you the formula then. 3-2 formula. It is on page 70. I just try to show you the formula. To calculate confidence interval estimate, we need SE formula. SE formula. It is a 70, not the same. So try to locate that formula. Okay, we need this formula here. Okay, so I'm just going to copy this formula to calculate confidence interval estimate for autocorrelation. So in this formula, when R equal to 1, so standard error for R1 equal to this actually goes to this formula assumes that any autocorrelation before time lag K is different from 0, and any autocorrelation at time lags greater than or equal to K is 0. Okay. So when K equal to 1, so this formula becomes just square root of 1 over n. Okay, just square root of 1 over n. Okay, so we are going to use this result to calculate to do the question C here. Where is my question C? Okay, question C. Okay. So confidence interval estimate. So because it is it is large sample, I will use normal distribution. Okay. So it is just 0 plus minus Z half alpha times SE at time lag 1. And we know when you have 95%, it is just the critical value 1.96, and then times SE when K equal to 1, it is just 1 over sample size. How many samples do we have? Sample size is 52 if you count. Okay, so it is just positive negative 0.272. Okay, and this number will be reflected on the output. On the output, you see for time this one here, upper limit, lower limit, one is point, not partial. Not partial RCF, but it is here. So something like this. This is upper limit, this is lower limit. Okay. All right. So any questions?
Can you just quickly show how to do the line graph again?
Oh, line graph using Excel or using SPSS?
SPSS.
Okay, in SPSS, where is my data? So is this the data? No. I have another data. Here, this is the data. No. Here. To do the line chart, you do graph, legacy diagram, choose line. Okay. And then you click simple. Click the last one, values of individual case. Copy. So after that, you click define. Line represents, initially it is this, you select cells into line represents. Okay, that's it. Then you click OK button, you will get the line chart. This line chart.
Thank you.
You're welcome. Thanks for asking. Any other questions? All right. In summary, what we did today, there is just one keyword. Autocorrelation is very, very, very important. From this class onward, we'll have autocorrelation. We'll talk about this. It's a very important concept, okay? Make sure you know what is autocorrelation and how do you calculate using formula and how do you calculate using SPSS, okay? Because during the test, they must have questions about autocorrelation calculations, okay? All right, any questions? We do have some time, usually in virtual classroom, it is, the school suggests give 2 hours, maybe 2 sessions of live lectures. Another time, you know, it is maybe question and answer, okay? So the lecture ends. The rest of the time, we have a few moments. If you have any questions, you stay for questions. If you do not have questions, feel free to go. Thank you so much for your participation. Next class, we will start with doing more questions, problems from chapter 3, and then we move to chapter 4. That is for next class, okay? Thank you again. Good night. I will see you next class. If you have questions, I will be here for next moment.
Yeah, quick question. Do we have to use SPSS on the exam? Like in order to answer the exam questions, do we actually have to have SPSS running?
I know, yeah, okay, I understand your question. Do we have a tool called POW? How many of you do not, so you are required to access SPSS, okay? You can use other softwares. So to answer the question, do we have questions about SPSS? We should have questions about SPSS because in class we did go over SPSS, but not a lot of questions on SPSS. Some questions are also concept questions, calculation questions, like the first questions I did in class today. Okay. You can use other softwares. I don't mind what kind of softwares you use, but I need the result, the correct answer. Okay. Thank you for your question. Any other questions? So I'm going to stop recording.